Welcome to the Cosmic Wild. Get ready to journey through the wonders of the universe. Today we're diving into one of the most powerful and mysterious forces from our sun, the solar storm. What are they? How do they affect Earth? And should we be worried in 2025? Let's find out together. The sun, our life-giving star, is a dynamic and often turbulent body. Its surface constantly churns with magnetic energy, leading to phenomena known as space weather. These events can have profound effects far beyond the sun's immediate vicinity. Understanding these solar phenomena is crucial in our increasingly technologically dependent world. As we approach the peak of the current solar cycle, the potential for significant solar storms becomes a pressing concern. Solar storms originate from explosive events on the sun's surface. The two primary types are solar flares and coronal mass ejections, or CMEs. Solar flares are intense bursts of radiation, traveling at the speed of light. Coronal mass ejections involve vast clouds of magnetized plasma ejected from the sun. These CMEs travel much slower than flares, but carry immense energy. If directed towards Earth, they can interact powerfully with our planet's magnetic field. The sun undergoes an approximately 11-year cycle of activity, characterized by the rise and fall of sunspots. We are currently in solar cycle 25, which is projected to reach its peak or solar maximum around 2025. This period signifies increased solar activity. During solar maximum, the frequency and intensity of solar flares and CMEs significantly increase. This heightened activity raises the probability of powerful space weather events impacting Earth. Scientists closely monitor these cycles to anticipate potential threats. When a powerful CME reaches Earth, it can trigger a geomagnetic storm. This occurs as the CME's magnetic field interacts with and distorts Earth's magnetosphere. The severity of the geomagnetic storm depends on the CME's speed, density, and magnetic orientation. One of the most significant concerns is the impact on electrical power grids. Large geomagnetic storms can induce currents in long conductors, potentially overloading transformers and causing widespread blackouts. Such events could disrupt critical infrastructure for extended periods. Satellites in Earth orbit are also highly vulnerable. Geomagnetic storms can cause increased atmospheric drag, leading to orbital decay. They can also damage sensitive electronics, disrupting communication, navigation, and weather monitoring systems. Global Positioning System, or GPS, signals can be degraded or lost during severe space weather. This affects not only navigation, but also precise timing signals, essential for various modern technologies. Radio communications, particularly high-frequency transmissions, can also be severely disrupted. History provides stark warnings about the potential scale of solar storms. The Carrington event of 1859, a supersolar storm, caused widespread telegraph system failures and auroras visible globally. A similar event today would have far more devastating consequences due to our technological reliance. Governments and scientific organizations worldwide are actively working on space weather forecasting and mitigation strategies. This includes developing more resilient power grid components and improving satellite hardening. International collaboration is vital for effective preparedness. While the prospect of a powerful solar storm in 2025 presents significant challenges, it also underscores the importance of scientific understanding. Continuous monitoring of the sun and advancements in space weather prediction are crucial. By understanding the risks and implementing robust preparedness measures, we can enhance our resilience against these natural phenomena. Our ability to anticipate and respond to solar events will define our technological future.